everybody, this is Meghraj and I welcome you to my YouTube channel. Today we are going to solve the next numerical from chapter electricity. This numerical was asked in board exams for 5 marks. So dear friends, listen to me very carefully. I'll read the first part of the question that I have not written here. I've written the second part of the question here. So this part is of 2 marks only. That is the calculation part. The conceptual part is for 3 marks. So the first part is, with the help of a circuit diagram, prove that when a number of resistors are connected in series, the equivalent resistance of the combination of resistors is equal to the sum of the individual resistances of the resistors. So we have to derive the expression for resistors connected in series. So dear friends, the first part is about the derivation, that is this part. And the second part is about the numerical, that is written right here. Okay, so let's go through the first part. So dear friends, in every derivation, or you can say before starting any derivation in physics, you have to go through the description about the derivation. So in this case, what will we say? We will say that consider a circuit containing 3 resistors connected in series along with a battery and a key to complete the circuit. And the ammeter is connected in series, whereas we have connected what? 3 voltmeters across each resistor. So this is the description about the derivation and also about the circuit right here. After this, what we'll say? We'll say that according to Ohm's law, we can give the potential difference, current and resistance of the circuit by V is equal to I into R. So till that, this was just the intro and the Ohm's law. After this, there is the important step. Now listen to me very carefully, dear friends. See, the basic thing here is the current that is passing from this point to this point will remain constant, whereas the potential difference across each resistor will be different. So in easy words, you can say that if from this point till this point, okay, exactly the shape, you can say just the shape of the line you can see here. If we have a pipeline which is laid down exactly horizontal to the plane, okay, we have a pipeline in such shape. Okay, and if I throw a 1 bucket of water from this point, okay, from this point if I throw 1 bucket of water, okay, forcefully, okay, with a greater force, now what will happen? The water will flow across this shape and the pressure or the force with which the water was flowing will reduce. Again, when the water passes from this shape, again the force will be reduced, that is the pressure of the water will be reduced, and again in this shape the pressure of the water will be getting around 0 only. So what does it mean? It means that the pressure difference goes on decreasing as per the number of resistors increase. So that is the main part, or you can say the conceptual part in this derivation, that is only one path for the current to flow. So current has only one path to flow, but the potential difference across each resistor is going to be different. So that we can observe by the help of the voltmeters connected across each resistor. After that, what we can say that whatever I said just now, that's what's here. You can see I remains constant across each resistor, but V will be different across each resistor. That is, the pressure difference across each resistor will be different. Whereas I, that is current, will remain constant across each resistor because current has only one path to flow. This is the main part. That's why I've written that in caps. Now, dear friends, according to Ohm's law, how can we get the potential difference across R1? V1 is equal to IR1. Similarly, across V2, across R2, the potential difference will be V2 is equal to IR2, and across voltage across R3, that is resistance 3, will be V3 is equal to IR3. This is also by the Ohm's law. Now, the total voltage of the circuit will be V is equal to V1 plus V2 plus V3. Now, dear friends, I just substituted the value of V1 from here V2 from here and V3 from here. That's it. Then what I did, I took I as common and then I throw I to the other side in denominator. So I will get cancelled, and what we will get is Rs is equal to R1 plus R2 plus R3. This is the expression for the formula when the resistors are connected in series. Okay, now let's come to the numerical part. Calculate the equivalent resistance of the combination of three resistors 5 ohm, 10 ohm and 30 ohm joined in parallel. Okay, so here the calculation is about the parallel connection. Okay, so this will be the formula for parallel connection. How can we describe this formula? We can describe this formula as the reciprocal of the equivalent resistance will be equal to the sum of the reciprocals of individual resistances. Okay, so what I did is I just kept the values 5, 10 and 30 ohms in the respective places, R1, R2, R3, and what I got is 1 upon Rp is equal to 1 upon R3. So dear friends, never stop at this point. You have to just take reciprocals of both and you have to write this. Okay, so this carries the mark. If you write till this, the marks may be getting deducted. So that's all for today. Thank you very much for watching this video. I'll see you in the next video. Subscribe to my channel and hit the bell icon to never miss a video. Thank you very much.